Hello, my name is Jamie Goggins, and in the third part of this short talk series, I'm going to look at the carbon footprint of the University of Galway as a case study. I'm going to have a quick look at what the impact of the COVID-19 restrictions have had on the carbon footprint of the university. We'll also look at commuting and working from home and how that impacts on the carbon footprint. Purchase goods and services methodology that we used in the university to work out the greenhouse gas emissions associated with that part of Scope 3 will also be explained, and how we do greenhouse gas visualization. The carbon footprint assessment for the University of Galway was conducted using the Greenhouse Gas Protocol Corporate Standard, which is one of the most widely used standards globally. This slide shows the preliminary carbon footprint calculations for 2017 to 2021 for the university. You can see that the greenhouse gas emissions varied from about 28 kilotons of carbon dioxide equivalent to almost 60 kilotons of carbon dioxide equivalent. The years 2017 and 2018 were pre-COVID-19 restrictions, whereas 2019 and 2020 were impacted by COVID-19 restrictions, and 2021 the university was back to be fully operational again. So from the average of the 2017-2018 greenhouse gas emissions, we can see the breakdown of the greenhouse gas emissions, where 8% is associated with Scope 1, which is mainly heating of the buildings. 18% of the greenhouse gas emissions associated with the university are to do with Scope 2, which is mainly from electricity consumption within the buildings around campus. Then if we look at Scope 3 emissions for the university, purchased goods and services were associated with 17% of the greenhouse gas emissions, which is similar to the amount of electricity that was similar to the amount of greenhouse gas emissions associated with electricity consumption within the university. The biggest portion of the greenhouse gas emissions is associated with commuting of the students and staff to and from campus. There are 21,000 full-time equivalent students and staff in the university. We'll look at that in a little bit more detail later on. Business travel accounts for 10% of the greenhouse gas emissions, and where waste and water accounts for 0.3%. 2019 and 2020 saw big reductions, mostly in commuting behaviour, due to restrictions in the operation of the university, meaning that many students and staff didn't travel to and from the university. Looking at 2021, you can see that the greenhouse gas emissions associated with commuting returned to the levels that they were similar to pre-COVID-19 restrictions. And also notice that from the 2021 data, there's a large amount of emissions associated with the construction of a new building, which is a similar quantity to the emissions associated with commuting. This is the construction of a new student accommodation on campus. With 21,000 full-time equivalent of staff and students associated with the University of Galway, outside of the years that were impacted by COVID-19 restrictions, the university carbon footprint was between 2.3 and 2.8 tonnes of CO2 emissions per full-time equivalent student and staff, which can also be expressed as between 0.29 and 0.39 tonnes of carbon dioxide emissions per square metre of buildings. Here in this graph, we can see a little bit more detail in terms of the impacts of COVID-19 restrictions on the emissions, where the values here for 2019, 2020 and 2021 are compared to the average values for 2017 and 2018. We can see that every category has dropped by some amount except for purchased goods and services, which, ironically, even though the university campuses were mainly closed during 2019, or at least for part of 2019, purchased goods and services for that year were still a little bit higher than the previous 2 years on average. Commuting clearly had the biggest effect, with a reduction of almost 12 kilotons of CO2 emissions, or a quarter of the entire baseline, which occurred due to just a 55% drop in commuting activity over 2019 and 2020. This is again due to the large significant restrictions in terms of activity on campus during 2019 and 2020, with most of the teaching being conducted online. Business travel saw the biggest drop within this category, reporting 88% less emissions than pre-COVID, but these have remained pretty low in 2019 through to 2021. However, my understanding is that these levels have come back up to pre-COVID levels again in 2022. Scope 2 emissions dropped by 45%, and Scope 1 dropped by 20%. These have also remained relatively low in 2021. Scope 2 emissions dropped significantly due to a large program of installing PV panels on top of the buildings throughout campus, as well as the installation of energy efficient light bulbs around campus and other measures. Looking into the data for commuting a little bit more, in 2021 the university had over 21,000 full-time equivalents when you add students and staff together. This is why commuting is responsible for such a high proportion of the institution's footprint. While most organisations aren't accounting for so many individuals, commuting is still likely to be a major category. However, if we look at the data a little bit closer, you can see what is really driving the emissions associated with commuting, especially from the staff. There's a very high dependency of car usage from staff, with 72% of staff driving to and from campus. You can see that 58% of staff commuting to and from campus, actually driving a car on their own, which is a very inefficient mode of transport. 1 in 10 staff members come to and from campus by bicycle, which is a similar proportion to those who walk to and from campus. See, there's a very low usage of trains, and only 1 in 100 people, as well as only 4 in 100 people using bus, minibus or coach. Whereas when we look at the students, nearly half of all students walk to and from campus, with a similar amount using a bike as the staff, which is 1 in 10. Similar with the train, only 1 in 100 use the train. However, there's a much larger portion of the students using buses than there are staff. You can see that there's then subsequently a lot less students travel to and from campus on a car, which with 20% of those students coming to and from campus coming by car. So depending on the size of the organisation, it may be necessary to use a survey to collect information if accounting for many employees. You need to get information such as the commute distance, so how many kilometres people are travelling to and from campus, the days and the weeks that people are commuting to and from campus, the method of travel, for example, walk, cycle, bus, drive, and if they drive, details about the vehicle, like such as the engine size, the age, the make and the model. If it's a small company, simply asking your employees the above list of questions will help to build a picture of the impact from everyone getting to and from work. There's a limited amount of research in the area of greenhouse gas emissions associated with working from home, but there is some information from UK government guidelines and Energize. To calculate the working from home emissions according to the UK government, you need to keep a record of information on the number of full-time equivalent working hours at which its staff were working from home. For each year, the total number of full-time equivalent working hours is multiplied with the conversion factor. It needs to account for office equipment usage and home heating. Now, please note that the home heating conversion factor is already taken into consideration both heating months and non-heating months. So users should multiply the heating conversion factor simply by the total annual full-time equivalent working hours instead of just the months that they require heating. Some examples there of on the right hand side of the slide, calculations by the Energize, which is the UK sustainability consultants. They assumed the employee working 46.4 weeks per annum, which is 260 working days minus the statutory leave of 28 days, at 42.5 hours per week on average, based on 10 cubic metres of office space per employee, and the UK average commute emission figures were used. So the figures there on the top right represent the percentage change per employee in Scope 1, 2 and 3 emissions conclusively. The XEO-based 3 database was used to estimate the greenhouse gas emissions associated with purchased goods and services at the University of Galway. The XEO-based 3 is one of the most extensive environmental extended multi-regional input-output systems available. Ignite Analytics used utilised exiobates to produce a list of emission factors that sum the global warming potential for all 200 product classifications, 49 regions and 12 years. That's from 2010 to 2022. These emission factors allow for financial data to be converted into global warming potential by simply matching up spin categories with product classifications from exiobates. Each product category has got an associated emissions factor, as you can see on the screen there on the left hand side. Here you can see some of the results from the analysis of the purchased goods and services at the University of Galway, which are the Scope 3 emissions, where we utilised the spin-based method as described earlier. You can see that construction was found to be the biggest category of emissions from the university's procurement, followed by lab goods, electronic goods, services and print and paper. It should be noted that the university's food consumption has mostly not been accounted for due to the unavailability of data from the food contractors. The measurement was achieved by matching a total of 71 of the university product codes with 23 different exiobate product classifications. The emissions from the new building, the construction of the new building, show how significant capital expenditure on work can be in terms of the organisation's greenhouse gas emissions. Discussed in the last talk, there are a number of different data types that can be used in our calculations. We can use the average data or supplier-specific data. So in the analysis for the University of Galway, we use purchase data, which is effectively, we converted the euro spend for each of the different categories and multiplied by that by an emissions factor, which was got from the exio-based 3. However, for in some instances where we had activity-based data, we use that. Or if we have specific supplier-specific emissions factors, we also use that. So effectively what we did is we started with the low-hanging fruit. So we started to identify opportunities for swapping spin-based estimations for activity-based calculations until the whole value chain could be more accurately understood. This is a work in progress and will continue to be improved all the time. You can find out more information on the methodology by going to the universityofgalway.ie/sustainability and going into the reports section to find the carbon footprinting reports. As mentioned previously, if we can get data from a life cycle assessment for the given product or service that we are procuring, it is a much more accurate method. It's more detailed and specific. It quantifies the carbon literacy, but obviously it takes more time and effort to produce a life cycle analysis for a product or a service. We'll discuss life cycle assessment in more detail in the later module. This is an example of a life cycle assessment that was conducted by one of the suppliers to the university, Dell, for one of its products, being a Dell Latitude 5510 laptop. You can see that there's a value in the range associated with the carbon footprint of that product, because these products might be made in different factories, or also the suppliers of components may vary across over different times or different geographical areas. So when estimating the greenhouse gas emissions associated with the purchased goods and services, in particular purchased goods and services of these laptops by the university, we can take each of the models and if we take the average price and the number that were purchased by the university from the exio base, it's just one emissions factor associated with the euro spend. So that will give us the total emissions using the spend-based calculations. However, on the right-hand side, you can see for the life cycle assessment calculation that each of the laptops, each of the models of the product have a different greenhouse gas emissions associated with them. So we can then work out the number of those laptops that are purchased, multiplied by the specific emissions factor associated with that laptop to get an emissions value. And comparing the life cycle assessment calculation to the spin-based calculation, you can see that there's a difference of 39%. So exio-base estimated the emissions from over 400 laptops with 61% accuracy. The University of Galway set out in its Sustainability and Climate Action Policy to become a net zero greenhouse gas emissions organisation. The first stage of that was to do the baseline carbon footprinting. So the greenhouse gas emissions in 2018 were 47,300 tonnes of carbon dioxide equivalent. The quadrangle in the campus is one of the iconic buildings and the oldest building on campus. So if we were to fill the footprint of the quadrangle with greenhouse gas emissions that were given off, that were associated with the university for a given year, how tall would the quadrangle have to be? Well, to be able to store 43,200 tonnes of carbon dioxide equivalent that's attributable to the University of Galway in the year 2018, and assuming that we don't compress the gas down, then we need the quadrangle to be approximately 4.5 kilometres tall to be able to store the amount of carbon dioxide. That's nearly 6 times as tall as Crowpatrick, the famous Pilgrim Mountain in the west of Ireland, or 4.5 times as tall as Currantoohil, Ireland's highest mountain. If we were to fully offset the carbon from 2018, it would cost about €1.2 million based on the rate of around €25 per tonne. To put that amount of greenhouse gas emissions associated with our activities in 2018 into account, if I managed to compress that greenhouse gas into similar density to stones, then I would need 2,400 trucks to take away the greenhouse gas emissions that we were responsible for in 2018 from the university annually. That's equivalent to the trucks parking bumper to bumper along the road from the university to around Athenry, Invern, Uachtarard or Headford, so about 20 kilometres or so. Imagine the traffic jam that would cause. The rough sketch that I've done here shows the equivalent area of Irish native woodland trees growing over 10 years that we would need to plant annually, that's every year, to offset carbon emissions. You can see that the university campus, just with scope 1 alone, most of the university campus is covered. And we take our scope 1, 2 and 3, much of the Galway city actually has to get covered in trees every year to offset the carbon associated with the activities in the university.